Hello students, welcome to another video on the chapter Heat for class 7. In the previous video we have discussed about the conduction method and today we are going to learn about convection and radiation. So let us begin. If you remember the example that I gave you last time, in which I told you that if the teacher is distributing paper, in the case of conduction I told you that the teacher is passing the bundle of paper to the students and each one is taking one and passing it to the other person. And for convection I had told you that the teacher is calling the children all in a line to her, in a line, giving them the paper and sending them through the other side. So when I talk about convection, here it is a process of transfer of heat by the actual movement of the molecule. You might have seen water boiling, right? You know that the lower part, because obviously the heat is supplied from the bottom, and when the lower part is heated, the hot particles, they start rising, the water molecule starts to boil, and the colder part which is above, it goes down. So there is actual movement of the particles which is seen in case of convection, and this is definitely happening in the fluid like the liquids and gases. Conduction was possible in the solid, but it's not possible in case of liquids and gases very well, because the molecules are far apart in case of the liquid and gases. So there is formation of convection current in case of convection, because as I told you that the molecules, they will get the heat, they will become lighter and they will move up, they will expand and the density will decrease, because of which they will rise above, and the particles which are on the upper part, they are cooler, so they will come down again, and this circulation is called the convection current. Now convection is one of the main methods of transport of heat in fluids. Now what are fluids? Liquids and the gases. And the substances on heating, they expand and they contract on cooling. And also you can see that the gases, they expand much more than the liquids for the same rise in temperature. So obviously you will see that the gases, they rise faster than compared to the liquids. Now where do we see the application of this convection and convection current? You might have seen that in winters the buildings, they are heated. So in winters the buildings, they are heated centrally on the principle of this convection current. There are pipes connected, they are heated from one end and the water moves upward because of the heat, and the upper water comes down and that also gets heated up. Similarly, land and sea breeze is also happening due to convection current, and also the process of convection is used to cool the engine, motors in the cars, etc. Now what is happening in land and sea breeze, let me explain you. During the daytime, as you know, if this is the land and this is the sea, and because of the heat of the sun, what is going to happen is the air near the land is going to get hotter fast, and hot air rises above. Always remember, hot air rises above because of the convection current. It doesn't go to side, it goes up when it's heated, because the air around the land heats up and rises above. The cool air from the sea will move towards the land to take its place. So as it is happening during the daytime and as the air is moving from the sea towards the land, we call that as a sea breeze. And just the reverse happens during the night. At night the land cools faster as compared to the sea. So as the land cools faster, the air above the sea is becoming hot in comparison to that of the land. So hot air above the sea will rise and cool air from the land is going to take the place of this hot air which has risen up. Now as the land cooler and the air around it is cool, it is able to move to the sea, and as the breeze is going from the land to the sea, we call this as a land breeze, and this is happening because of the convection current. Also the monsoons is happening because of the convection current, and this is the same reason, because there is difference between the land and sea temperatures, the hot air rising above forming the clouds and thus bringing rainfall on the land after the summer season. In radiation, the process of heat transfer does not rely upon any contact between the heat source and the heated object. It does not heat the medium. Here, directly the body, which is at a particular distance from the heat source, gets heated up. The best example is the sun's ray which falls on the earth. We feel the heat of the sun, but the medium does not get hot. So the heat transfer from the sun is reaching us by radiation, and it is in the form of the electromagnetic waves. Now the amount of radiation that is absorbed by any object depends upon three main factors. That is the color and texture of the surface. Now when we speak about the color and texture, here we mean that dull and you can say dark surfaces, they absorb more heat, whereas shiny and light surfaces, they do not absorb heat, they reflect heat. Also, you can say that is the reason why dark or black color, they are called absorbers. And all good absorbers are also good radiators. On the other hand, the shiny surfaces are bad absorbers but good reflectors of the heat radiations. So it is very important to remember that the color and texture of the surface, whether if it is dull, black and rough surface, it is the best radiator and the best absorber of the heat energy, whereas silvery, shiny and smooth surfaces, they are the poorest radiators and the poorest absorbers of heat. And that is why you can see that the fuel storage tanks, they have a shiny, silvery, smooth surface so that they can reflect the radiation and to keep the contents cool, otherwise they might catch fire. And the light colored clothes are worn during the summer, so this is one of the benefits. And even in the colder places, people wear dark clothes so that the body and the clothes can absorb a lot of heat and keep them warm. Next is the surface temperature. Obviously you can understand whether if the temperature of the surface is greater, then the amount of radiation also will be greater, the amount of radiation emitted by it. The sun emits more radiation than an electric lamp because the temperature of the sun is very high. Similarly, the last factor, that is surface area. If we have two objects which are of the same material and of the same mass, obviously the larger surface area will absorb more radiation. You can try this by doing a simple experiment by keeping two cans, color one with white color and the other with the black paint, and keep a thermometer on them and keep them in the sun for some time. You will see that the one which is colored black, the temperature reaches higher in that, whereas the one which is colored white, the temperature is not as much as the black one. So this very clearly will show that black surfaces are the best absorbers and radiators of heat than the white surfaces. Now let us understand some applications of the radiation. The application of heat radiation can be seen in the solar cookers. You might have seen that the solar cookers, generally the inner surface is painted black so that it can absorb the maximum heat and the food can be cooked faster. Even as I told you, the light color clothes, they are more comfortable in summer. People in the very hot region like Saudi Arabia and all, they wear white color cloth more because they are the bad absorbers and good reflectors of heat. Thus they keep the person cool in summers. The electrical room heaters, you might have seen the polished reflectors at the reverse side of the heating element so that the heat is reflected to keep the room warm. Also, the base of the cooking vessels is generally painted black, absorb most of the heat energy and so that they can cook faster. Even you might have seen in buildings which are painted with white color, they absorb the less heat and they remain cooler compared to the one with the dark color shades. Even in the car, the engine cooling radiators are painted black so that the heat of the engine is quickly radiated off. And this is the reason we can see that heat radiation is playing a very important role in our day-to-day activity. So if we do a quick comparison, you can say that conduction, convection and radiation. In conduction, it is a little slow process, generally happens in the solids, and liquid and gases also do conduction, but that's slower. But in case of convection, it is much faster than conduction and it occurs in the liquids and gases only, and radiation happens in solid, liquid and gases all the three states, but it is the fastest process. And conduction is happening mostly in the solids because the molecules are fixed at one place. They just start vibrating because of the higher kinetic energy. And actual movement of the molecules are seen only in case of convection, whereas there is no molecule movement in case of radiation because it's not heating the medium. Like if you keep an iron and the iron is hot, even by just putting the hand near the iron, not touching it, you can feel the heat of the iron. Even in thermos flask, you can see children, the day to day that we use thermos flask to keep the cold things cold and hot things hot, they are using different principles of this heat radiation technique, heat conduction technique, and heat convection technique. Like in that we have the inner wall, which is generally silvery. Outer one is either plastic or some kind of an insulator. There is a vacuum created in between the different layers of the glass, which is there in the thermos flask, and the heat loss due to convection is prevented by closing the mouth of the flask with an insulator like a rubber, plastic, cork. And the sides of the double wall, they are silvered. This will prevent the heat loss due to radiation, as you know that shiny surfaces are the bad absorbers and radiators of heat. And the whole system is enveloped in a thick plastic or stainless steel, which can prevent it from any sort of a damage. So with this, I'm very sure that heat chapter is very clear to you. You have understood the different mechanism and heat transfer techniques and how in a day-to-day life we implement and use the different methods and modes of transmission of heat. If you have liked the video, don't forget to hit the like button. Thank you for watching.